Example 3a, we have a pretty lengthy application of logarithms. So something that's kind of cool about logarithms is that formulas using logarithms can be used to measure numbers that get really, really big. So for example here, in December 2004, an earthquake of magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The formula log of I1 over I2 equals M1 minus M2 compares the intensity of earthquakes, where I is the intensity level determined by the seismograph, and M is the magnitude on the Richter scale. How many times more intense was the Sumatra earthquake than another earthquake that measured 8.7 on the Richter scale? First of all, you don't have to write all of these words down. I know this is a lot. So the big things that I want you to include in your notebook is this formula, so that you have that handy when we're in class. Now, something that you might notice here in our formula is that there isn't a base written for our log. It just says the log of some other stuff. So this is what is called a common log. And if you ever see a common log, that means the base is 10. So if you ever see something like this, the log of 100, the log of 100, there isn't a base written. It really means the log base 10 of 100. Okay, so that's called a common log. Anytime the base isn't written, the base is really 10. All right, so that's the first thing to notice here. So I'm going to rewrite my equation right below here. My equation was log, and we know it's a common log now because the base isn't written. The log base 10 of I1 over I2 equals M1 minus M2. All right, so let's figure out what numbers are going to go here. I is our intensities, and that's measured by our seismograph, the thing that's measuring our seismic waves. Okay, and that's also going to affect how we feel the difference, I guess, in a way. Okay, the M's are our magnitudes. Since I know that the Sumatra earthquake was stronger, let's use that as M1. So 9.3 minus 8.7 for M1 minus M2. And 9.3 minus 8.7 is 0.6. So the log base 10 of I1 over I2 is 0.6. Okay, from here, I want to figure out what I1 over I2 is. Okay, if I get I1 over I2 by itself, that's going to tell me how many more times I1 is than I2. So write this logarithm that we have, even though it looks a little messy with our fraction here, let's write this logarithm in exponential form. It really means 10 to the 0.6 power equals I1 over I2. So again, I1 over I2 is going to tell us what we get when we divide our intensities. That's what we want to look for. Now at this point, let's just type in 10.6 into our calculators, and that'll tell us our answer. Okay. Oops. 10 to the 0.6 power. Whoops. So that's 3.98 if we round. Okay, so something to think about for a second. If you look at 8.7 and 9.3, it doesn't seem like there's a very big difference in those numbers, but that means our seismic waves are almost 4 times as intense. So that much stronger, that much more damage that's happening. Even though our Richter scale values aren't showing a huge difference. All right, so this is again just one application of logarithms in kind of a cool way.